Linear inequalities. Well, we just finished working with linear equations. We recognized them because they had an equal sign. They were linear equations because all the variables had an exponent of 1. Now an inequality sign is going to replace an equal sign. There are 4 possible inequality signs: less than, greater than, less than or equal to, greater than or equal to. And all the variables will still have an exponent of 1, so they're linear inequalities now. Certainly a little bit different than linear equations. When we solved a linear equation, most of the time we simply came up with one solution. For instance, x is equal to 5. Assigning one value to the variable, that's it. Now solving a linear inequality, we're still going to get that variable by itself on the left-hand side, but it'll work out to be something like x is greater than 5. The inequality is solved, but we haven't narrowed it down to just one solution. There are still infinitely many solutions, every possible value greater than 5. Once we solve an inequality, get the variable by itself on the left-hand side in this form, we're then going to graph it on a number line. And just a rough sketch, number line, as you go out to the left, the numbers get infinitely small. As you go out to the right, infinitely large. So we typically like 2 numbers on a number line. Of course, we need 5, and 0 is a good reference number. At our endpoint 5, we're either going to have an open or a closed circle. The inequality sign will tell us whether it's going to be an open or closed circle. If the inequality sign is less than or greater than, we're going to have an open circle. If it's less than or equal to or greater than or equal to, we're going to have a closed or shaded in circle. So in this example, simply all the values greater than 5, and then we're going to show an arrow either pointing to the left or to the right where those solutions lie. All the values greater than 5 obviously lie to the right. Now the reason why we take the time to graph these is because it'll help us put our answer in something called interval notation now. Interval notation, first of all, it's an interval, so it has a beginning value, has an ending value. In this particular case, the solutions begin at 5 and they continue on to positive infinity. So technically, even though they don't end, that would what we'll substitute in there for our ending value. Now at the beginning and end of our intervals, we're either going to have a parenthesis or a bracket. A parenthesis means that endpoint is not included. It's not part of the solution set. A bracket means it is. So at the beginning here at 5, 5 is not part of the solution set, so we show that with a parenthesis. It's simply all the values greater than 5. For instance, 5 is not greater than 5. And we always have a parenthesis next to an infinity, since you can never actually reach infinity. So once again, we're going to solve a linear inequality, getting the answer in this form. We're going to graph it, and then we're going to write the final answer in interval notation. Another example, we solve the inequality. It may work out to be something like x is less than or equal to -3. If we graph it, of course we need -3 on our number line, and 0 is a reference. In this case, we have a closed circle at -3, since the inequality sign is less than or equal to, and all the values less than -3 lie to the left. Interval notation, here the solutions get smaller and smaller, so we state that it begins at -infinity, it ends at -3. We always have a parenthesis next to the -infinity. And in this case, -3 is less than or equal to -3. -3 is part of the solution set, so we show that with a bracket. So moving out now into actually solving a linear inequality, once again, the way we recognize them, we'll have one of those 4 inequality symbols, and all the variables will still have an exponent of 1. So basically, there's going to be 3 different types of linear inequalities. One is just a plain linear inequality, just like our equations. We solve it pretty much using the same steps, but there's one additional rule we have to keep in mind. If we ever multiply or divide both sides by a negative number, we're going to have to flip that inequality sign or take the opposite. We're also going to have a compound inequality, and a compound inequality is basically 2 inequalities combined into one. So you're going to recognize one of these because there's going to be 2 inequality symbols in one problem, and you'll always find the variable in the middle. And then we're also going to have OR inequalities, and an OR inequality basically is 2 inequalities linked together with the word OR. For instance, x is less than or equal to -7, or x is greater than or equal to -2. So identify which inequality it is, and then just solve it, graph it, and write the final answer in interval notation. So example 1, look at the problem. Obviously we do not have an equal sign, we have an inequality sign. All the variables still have an exponent of 1, so this is just a plain linear inequality. Same steps as solving a linear equation. Simplify each side, so the left hand side, distribute that -5. and combine like terms. Get all your variables you're solving for on the left-hand side. Now in inequalities, we do like the variables on the left-hand side, so I'm going to subtract x from both sides. And now get it by itself. Of course, get rid of that plus 15, subtract 15 from both sides. And get rid of that multiplication of -4, divide both sides by -4. And here I'm dividing by a negative, so I'm going to have to flip that inequality sign. Less than is going to become greater than, which leaves us x is greater than 3/2. We solved the inequality. We need to now graph it. On our number line, open circle at 3/2, arrow goes to the right. And interval notation, solutions begin at 3/2, they go to positive infinity, parenthesis and parenthesis. Example 2, another linear inequality. Simplify each side, distribute that 7. All the variables are already on the left-hand side, so isolate that variable now, subtract 28 from both sides, and divide by 7. Now it's a positive 7, so it's not going to change the sign in this case. So we solved the inequality, x is less than or equal to -7. Graph it, and interval notation. Example 3. Look and see what type of problem we have. We have two inequality symbols in one problem. So this is what we refer to as a compound inequality. Once again, notice the variable is in the middle, so all we want to do is isolate it, get the variable by itself in the middle. Still basically follow the same steps, get rid of any addition or subtraction first. So we want to get rid of that plus 7. In order to do that, though, we're going to have to subtract 7 3 times. There's 3 parts to this problem, the left, right, and the middle, so we're going to have to subtract 7 from all 3 parts. And divide 3 from the middle, the left, and the right, leaving us -5 is less than or equal to x is less than 7. At this point, we solve the compound inequality. We graph it. We already have our two numbers that we need on our number line. At -5 is going to be a closed circle, less than or equal to. At 7, open circle, because of that sign, less than. And the values for x, the solutions will lie in the middle. So interval notation, the solutions begin at -5, they end at 7, bracket at -5, parenthesis at 7. And example 4 is what we refer to as an OR inequality. Easy to recognize because you're going to see that word OR in between two inequalities. So you just solve each one. The first one, add 4 to both sides. X is less than or equal to -3. The second one, add 8 to both sides. X is greater than or equal to 7, not forgetting to carry down that word OR in between the two. At this point, we solve the inequalities, so we graph them. The first one, -3, closed circle, all the values go to the left. The next one, 7, another closed circle, all the values greater than go to the right. So we can see this graph is kind of broken up into 2 parts, which means interval notation, we're going to have 2 intervals. All the values less than or equal to -3, all the values greater than or equal to 7, not forgetting that word OR again. And in interval notation, we have a symbol that means OR. It's called the union symbol. It looks like a U, but it stands for the word OR. Not to be confused with this symbol, which stands for AND. Make sure you use the correct one.